Inverse trigonometric functions. This video will help you understand the inverse sine function, understand the inverse cosine and tangent function, use a calculator to evaluate inverse trigonometric functions, and then find exact values or variable expressions of composite functions which contain inverse trigonometric functions. Inverse functions. Let's take a little quick review here, and here are some helpful things to remember from our early experience with inverse functions. One here is if no horizontal line intersects the graph of a function more than once, the function is considered one-to-one, meaning every x-coordinate gets mapped to one y-coordinate and vice versa. Y gets only mapped to one x. So if they don't pass the horizontal line function, they're not one-to-one, and their inverse functions and their inverses will not be a function. But if they do pass this one-to-one test and this horizontal line test, then the inverse will be a function. All right. Second thing to remember here: if the point AB is on the graph of f, then the point BA is on the graph of the inverse function, and then we denote the inverse function f to the negative 1 power. The graph of the inverse is a reflection of the graph of the function f about the line y equals x. So reflecting across the line y equals x, which remember is this guy right here, reflecting across that line, what that does is it reverses our points, the coordinates of our points, and will give us the inverse of the function. All right, let's take a look now at the inverse sine function. So here's a graph of the sine function, and you can see here that we're drawing a horizontal line across here, and our sine function is far from one-to-one. We can see that the horizontal line is intersecting the sine function, in fact, in infinitely many places. Has to be restricted in order for us to have an inverse function. If we just took the inverse function of the entire sine function, then we don't have a function at all, because we could input one value. We could input one value here and get a whole bunch of values out, and that won't work as a function. Every input value, we have to just get one output value. So what we do is we restrict the sine function, and we only look at the sine function between negative pi over 2 and pi over 2. So from right here to right up there. And the reason we're restricting it is to make it one-to-one, and therefore the inverse of the sine function will be also a function. The reason we're picking negative pi over 2 to pi over 2 is because it gives us all of these values. It gives us all the values between negative 1 and positive 1, which are all the values we need. And so that's why we're starting at negative pi over 2 and then ending at pi over 2. Okay, let's take a look at the graph now of the inverse sine function. So as discussed before, if we want to take a look at the inverse sine function here, one way is just to flip the coordinates here. So I take all my x coordinates now and make them y coordinates, take all my y coordinates and make them x coordinates. So here is the sine function, just the regular sine function, restricted to our new domain, which is negative pi over 2 to pi over 2, and we're going to reverse the coordinates. So flipping x and y now, this is sine inverse over here. This is the graph of that. So what we're going to be doing here with the sine inverse is we are going to be entering values between negative 1 and positive 1. When we enter these values, what's going to come out are angle measures in radians, and you can see my angle measures in radians are going to come out between negative pi over 2 and pi over 2. All right, let's take a look at the inverse cosine function. Again, the cosine does not pass the horizontal line test, same problem that the sine had. So we're going to restrict this domain as well. But notice, if we went from negative pi over 2 to pi over 2, we're not going to get all of these values between negative 1 and 1. So what we do with the cosine is we restrict the values from from 0 to pi. We only want to look at this function from 0 to pi, and notice I'll get all of my values between 1 and negative 1 over that interval, and we get a one-to-one function here on that interval. All right, again, we're going to take this restricted cosine here, and we'll reverse the coordinates, and what we get is this guy right here. Just like the sine now, we're going to be the inverse sine, the inverse cosine, we're going to be entering values that are on the outside of the unit circle, either, in this case, an x-coordinate, since we're talking about the cosine, because the cosine represents my x-coordinates. We'll enter an x-coordinate out there, and once we take the inverse of that, it will output an angle measure between 0 and pi. All right, let's take a look at an example now for finding the exact value of the inverse sine function. So we're asked here to find the exact value of sine inverse of 3 pi over 2. So let's see. If we're looking at our unit circle, the value where my y-coordinate, my sine value, was 3 pi over 2. Remember, sine starts out at 0. So 0, square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. So here's my location where my sine is the square root of 3 over 2. And so what this is asking us to find then, this is asking us to find theta, the angle that we need with the regular sine function that will spit out this 3 pi over 2. Sine of what angle gives us 3 pi over 2? Well, here we talked about it on our unit circle already here. That is, let's see, this is an angle of 0. This is an angle of pi over 6, pi over 4, pi over 3. So we would say then sine inverse of the square root of 3 over 2 is equal to pi over 3. All right, now let's stop for a moment and practice this. So we're finding the exact value now of the cosine inverse of -1/2. So another way of thinking about that, this is asking us now to find an angle where the x-coordinate will split out this -1/2 right down here. That's another way to ask that question. Now when we answer this question, we want to answer it like that. Let's go ahead now and pause your video player and see if you can come up with this cosine inverse of -1/2. Okay, so we're asking, where is this angle that will give us -1/2? Well, remember, cosine is my x-coordinates. So I'm either going to have to be in quadrant 2 or quadrant 3 for my x-coordinates to be negative. Now, one thing to keep in mind here is that the cosine inverse, remember, is restricted. So we can only look at values between 0 and pi. So what that does is that excludes quadrant 3 as a possible answer here. So I'm definitely finding my answer now in quadrant 2. Let's see, we want to have 1/2, -1/2. So I want my x-coordinate to be small. So if I think about my 3 angles over here in this quadrant, remember up here, my x-coordinate is 0. So if I'm working my way now, this would be the square root of 0 over 2. This would be negative the square root of 1 over 2, and that is my location right there I want, because if I look at my x-coordinate right here, my x-coordinate is negative the square root of 1 over 2, which is just -1/2. So when I come down here and I say the cosine inverse of -1/2, I want to say that this now is pi over 2 plus pi over 6, because I'm going just that distance of pi over 6 there. So let's see, pi over 2 plus pi over 6, that's 3 pi over 6 plus pi over 6. So that's 4 pi over 6, which is just 2 pi over 3. Okay, now let's take a look at the inverse tangent function. So here is the graph of just our regular tangent function, and again, we are not going to pass the horizontal line test. Tangent function is not one-to-one, so we're going to have to restrict it. And what we want to do is just like we did with the sine and the cosine. We want to get all of the potential values here, which with the tangent are -infinity to +infinity. And we don't want to have any repetitions here. So what we do is we just take this one nice graph right around the origin here, and we'll restrict the values from negative pi over 2 to pi over 2, and we'll get all of our nice output values, and this will pass the horizontal line test. This is 1-to-1, so therefore we can have an inverse over that interval. Notice this is the same interval we used for the sine, negative pi over 2 to pi over 2, but different than the cosine. Remember, the cosine was between 0 and pi. Okay, if we graph the inverse of the tangent function, swap the variables just like we did before, and so here's what our inverse tangent will look like. So notice now, instead of just putting values from -1 to +1 with sine and cosine, we can have values from -infinity to +infinity. So it's a good time to kind of take note that input values for sine inverse and cosine inverse are only between -1 and 1. Any values outside of -1 and 1, we cannot evaluate the sine inverse or the cosine inverse. But with the tangent, we can. We can, in fact, evaluate anything from -infinity out to +infinity. Let's practice now finding the exact value of the inverse tangent. So we're finding the inverse tangent now of -1. Another way of thinking of that is right down here. What angle would we need to put into the regular tangent function so that we would get an output value of -1? So I think it's helpful to kind of think about our graph. Again, we're just from negative pi over 2. So negative pi over 2 to pi over 2 here. We're looking at the tangent. So why don't you sketch a graph of the tangent? And I think once you start to make your graph, you will remember where the tangent function would spit out a value of -1. So go ahead and pause your video player now and answer this question. Okay, well, I hope you figured this out, that remember at our a and -a coordinates here, we reach -1 and 1 respectively when we graph the tangent. So a quarter of the way across, the tangent function is going to be -1. 3/4 of the way across, tangent function is going to be +1. And after those points is when our graph really takes off here. So we need to say this. At what value here do we get this? So we need to find this quarter of the way across. Well, if this distance here is pi over 2, then this distance here is just pi over 4. So that location is negative pi over 4. So we would say tangent inverse of -1 is equal to negative pi over 4. Okay, now let's practice using our calculator to find the inverse of trig functions. All right, it's not going to be all the time that we end up landing at one of those locations on our unit circle where we know both the angle measure matching to the coordinates, the x and y coordinates on the unit circle. Sometimes we're going to be between those places, and when we're in between those places, we use a calculator to calculate these answers for us. So on your calculator, you will either see this cosine inverse or you'll see this arc cosine. Those both mean the inverse cosine function. Now, another thing, when we're doing this location on the circle, 1/3, where the cosine is 1/3, could be answered with degrees or radians. So you want to make sure your calculator is set in the correct mode, degrees or radians, for the situation. Now, in this practice problem, I have not mentioned either one, so let's try to do both. Let's do degrees for part A, and let's do radians for part B. So let's practice using your calculator in both situations. Now, depending on your calculator, you're either going to enter the value, then take the inverse cosine of it, or enter the inverse cosine, then put the value in. Try it both ways. One way will work, one way won't. So go ahead, pause your video player now, and let's answer the first one in degrees, the second one in radians. Okay, let's take a look. My calculator, scientific calculator, I'm going to take 1/3, 1 divided by 3, make sure I hit equals on there. Then I'm going to take the inverse of the cosine, which will give me the inverse cosine. Punch that button, and in degrees, I get 70.53 degrees. Now, I didn't specify what to round to, so as long as you rounded it correctly, then you're fine. You could even have written 71 degrees. That would have been fine as well. Okay, let's take a look now at the second one. Now, tangent in radians. So what I have to do, I have a mode button on my calculator. I hit the mode button, and it switches from degrees to RAD, which is radians. And now, once I get there, I'll take negative 35.85, inverse tangent, and it will tell me now in radians that I'm 1.54 radians. All right, let's take a look at a little bit more now of these inverses and how we're going to use them. One way we can use them is to solve for angle measures in either degrees or radians. We've already seen that. The other way we're going to use these inverse functions is we're going to use them when we solve equations. Remember, when we solve equations, we're always attempting to undo certain operations. Like with multiplication, we use division to undo that. Well, we're going to have equations in Chapter 5, our next unit, and in order to undo sine and cosine and any of our trig functions, we're going to use the inverse trig functions to do that. So you can see this. If I take sine of sine inverse or sine inverse of sine, they undo each other and leave me with x all by itself. Same thing is true for cosine, same thing is true for tangent, and as I mentioned, we're going to use this a bunch in Chapter 5 when we're solving equations. Alright, now let's take a look at another practice now, where we're going to do composite functions. And some of these functions are going to be inverses. So I'm asking you here to find the exact value if possible. Well, we find the exact value when we're dealing with locations that we know are on our unit circle. So if we're at locations we know on our unit circle, either an angle on our unit circle or of x or y coordinate on the outside of our unit circle, if we know those, go ahead and find it exact. If we're at a place that isn't identified on our unit circle, then we're going to go ahead and use our calculator. If we use our calculator, let's make sure we're in radian mode here. So make sure your calculator is set to radian mode. Go ahead and pause your video player now and try these three problems. Okay, first one, this is an x coordinate value. If I'm taking the cosine inverse, that means I'm looking for an angle here for this x coordinate now of 0.7. Well, that's not something I know on my unit circle. So I'm going to use my calculator. So 0.7 inverse cosine. It's going to spit out 0.795 in radians. If you're in degrees, then you got to go back and switch it to radians. Now I want to take and evaluate the cosine of that. So I'll hit regular cosine of that. And notice it's going to bring me right back to the 0.7 that I had before. Okay, let's take a look at B. And you might be tempted to say that sine inverse of sine of pi is just going to be pi. But I think that would be an incorrect answer here. And let's take a look at why that would be the wrong answer. The reason that's the wrong answer is because we had to restrict the sine inverse only between negative pi over 2 and pi over 2. So we can't output a value from sine inverse that's pi. So let's take a look at our unit circle and figure out what this answer is. So the first thing we're going to do is we're going to take the sine of pi. So we're coming over here, pi radians. And at this location, I have the coordinates negative 1, 0. So my sine of that is going to be 0. So when I do that part there, this is what I would have. I'd have now sine inverse of 0 equals, because that's what the sine of pi was 0. Well, the sine inverse can only output values between negative pi over 2 and pi over 2. So we want to look on this interval and see where we would get an angle measure where the sine would be equal to 0. So this is what we're asking. Sine of what angle is equal to 0 on this interval? Well, the answer to that is at 0, because at an angle measure of 0, I have also a sine value of 0. So this actual answer there is going to be 0 radians. Alright, let's take a look now at C. And let's make sure, just like in B, that we can actually evaluate this thing. If we can evaluate this thing, we'll see. But we can't just immediately say it's negative 1.2 without investigating. So let's see. So the cosine inverse, remember, is restricted between 0 and pi. So I can only take angles between 0 and pi. And this thing is trying to find us an angle. This is asking cosine of what angle gives us negative 1.2 for an x coordinate. Well, if I go around on my unit circle, my negative x, the smallest this gets as I'm coming around here, would be negative 1 at this location. I would have an x coordinate of negative 1, and then traveling even further it's going to start to decrease. So really the maximum value I could ever get out of cosine inverse is between 1 and negative 1, right? And so this is outside of our range. So this is not possible because this is outside of our unit circle range, which is limited to 1 to negative 1. So this is impossible to do. So we need to be careful with sine inverse and cosine inverse here. We could obviously do A and come up with an answer, but in both situations of B and C, we came up with answers that were either not expected or impossible to do. So we want to be really careful when we're doing these problems. Okay, now we're going to practice using a triangle. We've used a triangle before to find trig values. So we're going to use a triangle here. And what that will do is it'll help us find the exact values. If we just plug this into our calculator right here, this would give us an approximation, but we can actually find the exact value of this. So what we want to do is we want to draw a little sketch of our unit circle. We want to find the location of this. Remember what this is asking, sine inverse of this value is saying sine of what angle would give us 6/10. Sine inverse is asking us to find this angle theta. And when we find this angle theta, what it's going to do is it's going to spit out this positive y coordinate of 6/10. So we know, since the inverse is restricted from negative pi over 2 to pi over 2, this point has to be somewhere up here. 5/10 would be halfway, which would be our kind of our 45-degree angle. So this is going to be a little bit more than that. So that's where that is. So what we want to do from this location is draw our triangle in. This is going to be our angle theta here. From there, we want to draw our triangle in and label the values in our triangle. And then once we've labeled the values, then we could take the tangent then of this angle. Remember, this is an angle, which will be this angle theta. So I don't want to give it all away, but go ahead and pause your video player now and give that a shot. If you can't get it, just go ahead and work on it a little bit. It'll help you understand when I show you. Okay, so as discussed, we want to draw our right triangle in here. Now, we know the sine value is my y-coordinate over my radius. Well, if this is 6/10, then I know my y-coordinate is 6 and my radius is 10. So notice, excuse me, we're not on the unit circle here. We're far from being on the unit circle here. So once I know those things, I know my radius is 10 and my y-coordinate here is 6, we can go ahead and find my x-coordinate here. We can use the Pythagorean theorem to find my x-coordinate. So I know that the hypotenuse squared, which is 100, is equal to leg squared, 36, plus, this is my x-coordinate down there, plus x squared. So let's see, subtract 36 from both sides. I get 64 as x squared. I find that x is equal to 8. Now I know that x is equal to 8. I have all the values of my triangle. Once I have all the values of my triangle, I could find the trig. I could take any trig function of this angle theta and figure out what it is. For example, if I asked you here to find the tangent, like I did, the tangent, remember, is opposite over adjacent, or my y-coordinate, sine value over my cosine value. So actually, let's answer this problem, then we'll look at some more here. Tangent of this angle theta, which we found here, this was an angle. When we take the tangent of that angle, it's 6 over 8, which can be simplified to 3/4. But really, at this point, I could have asked for any angle, not just the tangent. Note if I asked for the cosine here, then the cosine would have been 8 over 10. All right, let's take a look at question B here. And notice in question B here, I've got a variable in there. So I am not going to get a numerical answer for this like I did up here with this situation. we still want to draw our triangle in here, and we want to do this very similarly. Remember that the tangent inverse of this is going to be some angle theta, just like the sine inverse of this was some angle theta. So what we want to do is we want to draw our triangle, and we want to draw our triangle between negative pi over 2 and pi over 2, because that's where the tangent inverse is defined. Now, we don't know whether this x is positive or negative, so you might as well just put it up here in the positive coordinate. It'll make it easier, and it won't make a difference in terms of our answer, but it will make it a little bit easier to do. So go ahead and draw your triangle up here in the first quadrant, and try to figure out how to represent this angle. Once we get that angle, we can take the cosine of that angle, and our answer here is just going to be a variable expression. So go ahead, pause your video player now and answer this question. Alright, as discussed, we're drawing our triangle somewhere here. It's going to throw some point up there. And let's see, what we know about this angle theta is that if we take the tangent of this angle theta, it's going to give us 2 over x. Now remember, tangent is sine over cosine. So my sine value is going to go right there. That's my y coordinate. And my x coordinate is going to go right there. That's my x coordinate, or my cosine value. Okay? So now what I want to do, since I'm going to try to take the cosine of this angle now, I want to take the cosine of this angle. In order to do that, I'm going to need to know what this radius is. So I'm going to use the Pythagorean theorem, since we have a right triangle here, to figure out this radius r and figure out what that is. So I would know this, that r squared is equal to these 2 legs squared, x squared plus 4. Well, to solve for r there, I'm just going to take the square root of both sides. Okay, so r is x squared plus 4. Now, as discussed, the cosine of this angle here is going to be my x coordinate, my x value there, divided by r. So this would be, my x coordinate was just x, and my r is the square root of x squared plus 4. Now, we need to rationalize that denominator. So I'm multiplying the top and the bottom by x squared plus 4. Let's come down here to write our answer. So this guy is going to equal x times the square root of x squared plus 4. And then when I multiply these two together, that's just going to give me x squared plus 4. Now I don't have any common factors or anything I can divide out there, so that is the variable expression that describes the cosine of this angle we get when we take the inverse tangent of 2 over x.